Good morning, everybody. My name is Sri Krishnamurthy, and in this module, I'm going to talk about how neural networks work. So let's first understand the setting of a supervised learning problem. So in a supervised learning problem, you have three components. First, we have the input variables, and in this particular case, these are independent variables, and it could be either numerical or categorical in nature. And the whole goal is to map these independent variables into dependent variables. In this particular case, we'll call them as Y. And these Y variables could be either numerical or categorical in nature. If the Y variables are categorical in nature, we call it a classification problem. And if the Y variables are numerical in nature, we call it a prediction problem. And the goal is to find a mapping function which maps these independent variables into these dependent variables. So let's see how a neural network algorithm could be used to map these independent variables to the various dependent variables. We'll take a very simple example. And in this particular case, our goal is to label images of cats and dogs to their respective cats and dog labels. So in order to do that, we have a training data set. We have a bunch of images of cats and a bunch of images of dogs. And these are labeled so that we have these labeled pairs of X and Ys. And our goal is to build a model so that when we have a new image, our model will basically tell whether it's a cat or a dog. So let's see how we can accomplish that. So before we get into the mechanics of how the model actually works, so let's understand some terminologies in a neural network. In a neural network, you basically have layers, and you need to define how many layers are going to be there in your neural network. And in each one of these neural network layers, you need to define how many number of neurons you're going to be having. And then you have these connections, which are basically going to be the linkages between the individual neurons and in the input and the output input nodes. And the whole goal is to basically pass these inputs and then understand the various parameters of your neural network model, which are going to be deduced by various methodologies and come up with the label, which could be either of that of a cat or a dog. So in this particular case, we are extracting the pixels from these images and passing them as inputs. So when we look at it structurally, the neural network model looks something like this. We have simplified the number of layers. We have basically just taken one layer and one neuron in this particular case. And these X is just a representation of all the pixels we're going to be passing as inputs. In this particular case, what we are trying to do is we are basically trying to build out a function which is going to be a weighted product of the individual independent variables and the respective weights. And when it goes through an activation function, we're trying to determine what the output is going to be. So a couple of things to understand. We are trying to understand the weights in here. And these weights need to be deduced. Because these neural networks are iterative, so you are going to come up with a random set of weights and then iterate over and over, trying to figure out what are the best possible weights which would be able to map these X and Y variables. So the second thing you need to understand is the activation function in this particular case need not always be linear. We could also use non-linear activation functions. Algorithms like ReLU have been extremely popular nowadays, and you could basically substitute just a linear weighted function with a nonlinear activation function in this particular case. And then the third thing you need to do is to understand how do we get these weights. There are various algorithms, and the most popular one is gradient descent, which would be used to deduce these particular set of weights. So once we have this in play, we need to think about how are we going to take these output variables and then transform that into a probabilistic metric, so that with certain degree of confidence, you could say whether it's a cat or a dog. And in this particular case, we're going to use a sigmoid function to transform these output variables into a 0 to 1 scale so that you can figure out, basically generate a probability number, which could be used to figure out whether the image you are processing is either a cat or a dog. So we'll understand some of these concepts in more detail in the next module, but in this particular module, I thought we'll introduce you to some of these terms. And let's get to the next module where we'll understand this algorithm in much more detail. Thank you.